Okay, hello, this is Greg Deckler, and today we are going to be building a no-code machine learning regression model using Power BI and AutoML. So this works with Power BI Premium, so I'm in my Power BI Premium workspace here. What we're going to do is we're going to connect to some housing data, and we're going to build a machine learning model that predicts the price of houses. So first thing we're going to do is we're going to create a new workspace. So we'll create a workspace. Now this only works in the new workspace environment where you get allowed to create data flows, because we're going to use a data flow to connect to our housing data and then associate a machine learning model with that. So I'm going to name this workspace. We'll name this workspace Housing ML Workspace. And we don't really need to fill in anything else. As you can tell, we have an upgraded workspace, and we don't really need to mess around with this, although we do want to make sure dedicated capacity is on, because that makes it a Power BI Premium workspace. And we'll save this. So now we're in our Housing ML workspace, and we can tell that it's premium because we have a little premium content diamond. And what we want to do is we want to create a data flow. So once this comes up here, okay, so what we're going to do is there's a couple options here, but what we're going to do is we're going to define new entities. So we're going to click on this add new entities. And what I have is CSV file sitting out in GitHub. So that's what we're going to use to connect to it. So what I need to do is find the text CSV. I've got my URL here, and I've got this set up. So KC House Data CSV is just sitting out in my GitHub repository with anonymous access. It's just public data. And what we see here, Dataflows is essentially Power Query in the service. So it looks very similar to what you would look at in Power Query in Power BI desktop. This is the data. So we have ID, we have a date, price, number of bedrooms, bathrooms, lots of different dimensions for this data. Don't really need to mess around with any of this, but we do have similar functionality to what we have in the desktop as far as being able to transform this. Luckily for us, we don't really need to do any transforms, so we're just going to hit save and close. Got to name our data flow, so we're going to call this housing prices. I guess I could have named my query, but I always forget that step. That's okay. So now that we have our query created, you have this little brain icon here. So apply an ML model. So what we can do here is we can click on this and add a machine learning model to this. So the entity name is query. What we want to try to predict is price. So we click next. Now what it's done, it's already said, okay, it looks like what you're trying to do can be solved via regression. If we think differently and we don't think that what we're trying to do is a regression model, we can pick a different model. But in our case, yes, we are trying to use regression based on regional factors. So estimating house prices in a market based on regional factors. So we can click next. Now, customize inputs. What it's done, it's gone out and looked at the data and said, okay, these are the ones that I recommend including in this machine learning model. These other ones have a low correlation. Now, when I first did this, I didn't trust it, so I clicked on the ones that I thought had a correlation or should be correlated with price, and I got about an 84% confidence model prediction. So we're just going to go with what it thinks we should do and see if we can get it higher than that. So the question becomes, is Greg Deckler smarter than AutoML? All right, so now we just have to create a model. So we'll call this price predictor. And we don't need to, we can set some things here. So basically you have the maximum algorithm search time. How long is it going to take? Are you going to give it in order to look for the most optimal solution, essentially? We have our price, we have our input fields, a little bit of information about it. All we have to do now is hit save and refresh. So now it's created the housing prices, and if you saw that, it had the price predictor training model and then the result set. So basically it's doing the same thing in terms of splitting that data out into a training set and a scoring set. Now this is probably going to take anywhere from about 8 to 10, 12 minutes in order to go through and chug everything. So I'm going to pause the recording and I'll come back when it's done. Okay, we are back, and our refresh is now completed. You can actually look at that by going to refresh history. We can see that it took 11 minutes, and we have a completed status now on this refreshing the data and applying the machine learning model, essentially. So now what we can do is we can then click into our data flow that we have on housing prices, and it comes up here. Give it a minute. So now what we have to do is we have our predictor training data and our testing data. So this is your kind of your training data set in a traditional machine learning model. If you know much about how to do machine learning, you split your data into a training set and then into a scoring set. So that's what we have here. We price predictor training set, testing set. So now what we have to do is we have to then apply this to this model. So we say, click on our price predictor model accuracy preview, and it's going to generate this performance report. Okay, so as you can see, it's generating the performance report. We're just going to go ahead and click apply model because it has to refresh the data, which is going to be a little bit of a pause, and then I'll show you the report here. So we click apply model. We're going to apply the price predictor. We apply it. So now what it's created is a query enriched price predictor and a query enriched price predictor explanations. So we have to refresh this. So we're going to refresh it now. Again, that's going to take another about 11 minutes or so. But in the meantime, I'm going to show you the report. Let the report load up here. Okay, so there we go. 97% model performance. So 97, and you get a graphic here about what you're looking for in a regression model is for things that fall along this kind of line, right? So this is the predicted value, and this is the actual value. So you want kind of more or less, 45-degree angle or as close to it as possible, right? Or a straight line, essentially, and everything clustered around that line. That's what we see here. So we can see that, for example, the predicted value was $4,407, and the actual price was $4,424. So, pretty accurate. And then it gives you a little more information down here. We can see that there were 48,202 input rows. It sampled that data. It trained on 38,000, and then it validated on the remainder. And we can even see what the key influences were around the price prediction, and we can see that it was the hour of date time, and it basically when you were selling the house, essentially, was a large indicator around the prediction. And it's using a light GBM regressor, which doesn't mean anything to a business user, but data science, that's a data science-y thing. And then we can even, if my mouse would work here, we can even go over here to training details and get a little more information. This is more for the data scientists, right? That they want to see how this model was actually created in terms of the parameters that were used, how many iterations were run, and that sort of thing. So once this loads up here, so here down here we can see the light GBM regressor final parameters selected. So it actually was. So these are all things that can be tuned within that algorithm in order to increase the predictive value of the model. And so it actually goes through and does the parameter sweeping for us. We don't have to worry about that as a as an end user. And then we see that they ran one iteration and sampled rows, again the training rows and all of that. So let's go back and check on our data flows. And we'll see how we're doing with the refresh. So here's our housing prices, and here's the query enriched price predictors and all of that. We look at all right, so if we come down here to our data flows and we look at the refresh history, we can see that we've got 3 minutes and 33 seconds left. It's still in progress, so I'll come back once that's complete and we'll finish up the video. All right, so we're back after a short break here. We can tell by going to our refresh history that now our latest refresh took considerably shorter time. It's completed. So now what we can actually do, now that we've got this applied, is we can go into Power BI Desktop. And here I can actually go to Get Data and say Get Data from Power BI Dataflows. And give it a minute. Okay, so here we have our Housing ML workspace that we just created. Go to Housing Prices, which is, now we can see our price predictor, and what we want is our query enriched price predictor. We click on that. We don't really have to wait for the preview. Let's go ahead and load this data. Okay, we've allowed that query to complete. So now we should have in our data model, here is our query enriched price prediction data. So we have all that same data we saw earlier. And at the very end, we have the price predictor regression result. So this is the predicted price. We have an explanation and an explanation index in that. If we're so inclined, we can go here and we can say, create a new column here. And we'll say that this is price minus price. The result of that, we will wrap that there, do an ABS on it, and divide that by the original price, which should give us a percentage. Here's our percentage error, basically, for every one of these. As you can see, if we sort this, wrong, I sort ascending. There we go. So as you can see here, then we have a lot that are really, really close, within, no error to far less than a percentage of error. And we can scroll for a long time, and we're still only in the 4% error range when we're through, a good third of this data. So that is building a price predictor regressor for housing data with zero code in Power BI and using Dataflows. If you noticed, we didn't really need to know much about data science at all in order to go through this exercise and apply machine learning to our data and our data analytics. So with that, I will sign off.